Hi. You're probably wondering what this weird getup I'm wearing is. I stole a headband from a younger sister, and I have electrodes connected to my forehead and my ear. And so this is a YouTube video for my 375 project. Our group was called PDG, Pal the Goat, and our group title or project title was Whatcha Thinkin. And so essentially what this project is a microchip pipeline to reading brain signals and allowing them to control a BCI, a brain computer interface, which is a Python game that I developed. So let me show you the circuitry. Oh, yes, sorry. Let me introduce an EEG machine first. And so an EEG machine reads the electrical signals inside your head, and that's what the silly getup is for. A typical EEG machine will consist of about 20 nodes. Our simplified version only has 3. A reference node and 2 actual nodes collecting data on FP1 and FP2, and there's more nodes and locations, but this is the easiest for our implementation. So let me show you the circuitry. Now, I don't have fancy diagrams or projector to show you much, so this is going to be just a quick run through of it and then a live demonstration, and more explanations can be found on the GitHub or at our final presentation. So our circuit design is comprised of 7 main parts. We have the amplifier, initial signal amplification. EEG signals are very weak. Then we have our first 60 Hz notch filter, which is intended to remove power line noise. You can see all these live wires. We want to reduce that. And then we enter a 7 Hz high pass filter, which removes galvanic skin response from the head. High pass filters actually work kind of the opposite to their namesake. They only allow signals higher than that threshold, which is our threshold was 7 Hz. Then we have a 40 Hz low pass filter, so we don't collect signals higher than 40 Hz. Then we move on to a 1 Hz high pass filter, which ensures we get no extreme low frequency noise. Excuse me. And then we move on to our second 60 Hz notch filter, which is just intended to remove and clean our signal further. And then finally, we move on to part 7, which is our analog to digital converter. And so essentially, it's very hard for the Arduino to read our raw data, as it's very minuscule, and it's very much easier to introduce a middleman, which is this blue part right here. And essentially, like I said, amplifies the signal even further, reads it even better, and converts it from an analog to a digital signal. And so that's essentially the run through. Let me show you some of the code. So here we have our first file. I'm not gonna go into too much depth on this. Like I said, this is just intended to serve as a live demonstration. So let me go ahead and run it. Well, it's already running, but I'll run it again. So there we go. Now our Arduino is collecting data. As you can see, the light is on, and that is connecting our raw EEG signals, and then we're essentially processing them a little and then formatting them pretty like for Python to be able to read them even better. So now we go to our Python file. Here we go. Once again, I'm not going to explain it. It's a lot. And so let me go ahead and run that. It's going to take a little minute for the data to load in. And there we go. It started to load in. And so essentially the way I currently have it implemented is that if the gamma waves are stronger, the character moves to the right. Gamma waves consist of 30 Hz to 100 Hz signals, and then beta waves actually consist of 13 to 30 Hz. And so right now you can see I'm only moving to the right, and that's because we're mostly collecting gamma waves right now. They run in tandem together, so they occur simultaneously. And that's happening because I'm actively thinking and talking, and so those are gamma waves occur when your brain is being more active, essentially. And so if I were to calm down and go quiet, you'll see You can see that the character started moving to the left, and so currently this implementation only moves the character essentially with a binary choice, left or right. I still have a little more time, so I may implement some graphs so you can actually see the brainwaves and maybe change up the movement or such. But yeah, as you can see the live demonstration, I'll go quiet once more so you can see again. Ooh, that time we made it all the way to the left. But yeah, that concludes our project. Thank you for watching.